Happy New Year's from Voyage Beyond Earth. Today we'll talk about the solar system and the 8, not 9, 8 planets around the Sun. The solar system is the name given to our Sun and any other object that's gravitationally bound to it. Our solar system from the Sun to the Oort cloud goes from Mercury, Venus, Earth and Mars, the asteroid belt, Jupiter, Saturn, Uranus, Neptune, the Kuiper belt, a planet X or planet 9, any wild debris or asteroid that's coming from the Oort cloud, and finally the Oort cloud itself. Today we talk about this and more on Voyage Beyond Earth. Let's talk a little about each. Mercury is a rocky planet and despite being the smallest, is the second most dense planet in the solar system. Its day is longer than its year and this makes one side very hot and the other side very cool. Venus is the brightest planet in the solar system. Its atmosphere is 96.5% carbon dioxide and the rest is nitrogen and sulfuric acid with trace amounts of oxygen. Earth needs no introduction. It's the place where you live, breathe, grow, and watch videos just like this. It's the only planet in the solar system that we know hosts life. Intelligent life. Almost 7.5 billion intelligent lives. Mars, the glorious red planet that we're going to talk a lot about in these videos. Approximately 4 billion years ago, scientists estimated Mars to have been very Earth-like, with a large liquid ocean, frozen poles, and warmer conditions. Next, we have the asteroid belt. It exists mostly between the orbits of Mars and Jupiter with an estimated total mass of 3 × 10 to the power of 21 kilograms, which is just in fact 4% of the mass of our moon. It also hosts the smallest and the only dwarf planet in the belt, Ceres. Jupiter is 5.2 astronomical units away from the Sun. An astronomical unit is the distance between the Sun and the Earth, roughly 150 million kilometers. Known as a bigger brother, the powerful gravity of Jupiter is often credited to have flung asteroids coming towards the inner solar system outwards. However, in the year 1770, a comet passed relatively close to Earth. The comet would have been millions of kilometers away, if not for Jupiter's gravity pushing it towards us. So yes, Jupiter is helpful, but to what extent? Saturn is not the only planet with rings. Jupiter, Neptune, Uranus, all of the gas giants do have these rings. But Saturn has the most prominent and visible ones. Uranus is the second to last planet with winds up to 900 kilometers per hour. Lastly, we have Neptune with an atmosphere comprising mainly of hydrogen, helium and methane, making it very, very cold. Next, we have the Kuiper belt. The main difference between the Kuiper belt and the asteroid belt is the fact that the Kuiper belt is almost 20 times as wide and comprises of ice volatiles, while the asteroid belt is mainly rock and metal. It also hosts 4 known dwarf planets, Eris, Pluto, Makemake and Haumea. Caltech researchers Konstantin Batygin and Mike Brown created a simulation with the 9th planet, outside the Kuiper belt, because it was a commonly known fact that the dwarf planets had a very awkward inclination to their orbits, and a planet with a revolution of about 15,000 years and 10 times the mass of Earth seemed to perfectly match our observations of the dwarf planets. We have not yet spotted this 9th planet, but it's very likely. Named after the Dutch astronomer Jan Oort, the Oort cloud is this icy rocky sphere of debris that surrounds the solar system. The edge of this cloud is often called the cometary nucleus. It blows my mind how one of the smallest things in our universe is spherical, just like this giant protective shell around the solar system. Maybe protective isn't the right word here, because most, if not all, long period asteroids are coming from the Oort cloud, and you never know, one might be heading our way right now, 2,000 astronomical units away. Closer to home, let's talk about the Sun. The Sun produces 3.8 times 10 to the power of 26 watts of power per second. It does this through a process called nuclear fusion, where atoms are under immense heat and pressure transformed into newer, more dense elements. At this moment, our Sun is 90% hydrogen, 9% helium, and the rest 1% is majorly oxygen, carbon, and nitrogen. The Sun, just like the Earth, has layers. It has a core of over 15 million Kelvin, a radiation and convection layer that helps take the heat from the core to the photosphere in an efficient manner. And then it has the corona that extends millions of kilometers out. It is in the core that the fusion occurs. In the core, 4 hydrogen atoms are under so much heat, the strong nuclear force can be overcome, and these atoms are squished together and particles collide to create a helium atom, releasing a positron, gamma radiation and a neutrino in the process. A common question is that in such a massive gas object, why doesn't gravity just make it collapse into something smaller? And the answer to that is the heat pressure balances with the gravity that is pulling it together. Once the star runs out of hydrogen, the heat pressure reduces and gravity makes it smaller and smaller until helium can start turning into carbon with this increased heat pressure. At this point, the star starts to expand. Our Sun would reach this state in about 5 billion years, engulfing the inner planets, probably even Earth. We also must learn how Earth was formed and how elements such as gold, copper, silver are all found in our crust. A really cool thing, at least for me, was to find out that a probable distant supernova from a dying star. A supernova is just an explosion of heat and matter as a red giant explodes after it runs out of fuel, formed the solar system. Now this gas and dust sort of swirls around until certain areas start to bundle up into small packets. These are called planetesimals. A lot of planetesimals starts grouping together into planets. Much of these planetesimals are kicked out of the inner solar system and extend out to create the OORT cloud. A lot even go to the asteroid belt and the Kuiper belt. Our solar system was formed approximately 4.6 billion years ago. The last part of this episode we'll talk about the Goldilocks zone. We're honestly pretty lucky to be alive. There are billions or even trillions of planets around the universe, and thanks to Kepler, no, not the scientist, the Kepler telescope, we have been discovering these exoplanets. The Goldilocks zone is a region around a star where conditions are just right for liquid water to exist. Astrophysics does involve a little math, but you don't have to understand the formula, but intuitively look at it. So this region is calculated by the following formulas, where we find the absolute magnitude from the observable or apparent magnitude. Then we find the bolometric formula, which is the radiation from the star across the EM spectrum, not only just the visible light. Then we calculate the absolute luminosity, which we can use to calculate the furthest point and the nearest point where liquid water could exist. This is between 273 and 373 Kelvin. In tomorrow's episode, we look at the origins of life and the history of spaceflight. Thank you for watching the first episode. See you tomorrow on Voyage Beyond Earth.